As we said, this has been the second lecture, second part of the risk assessment, where we have actually been initially discussed on the overview of the outline. And just to share the brief outline, maybe in the next couple of I will just try to provide a quick recap as it's been 2 weeks, especially for the early toxicologists, just to catch up the concepts there. And we have started with the thinking about the introduction. Then we actually dwelled into the definitions. Then basically we navigated from how actually the decisions have been made, and finally touching upon the four major steps for the risk assessment, which have been the hazard identification, dose response assessment, and the exposure assessment, and the risk characterization. So we will be going in detail with regards to the exposure assessment and the risk characterization in this session. So again, as I said, just a quick recap, what all we covered, what exactly has been a risk assessment, and then basically we tried to touch upon on the different facets of the paradigm, like how actually the risk assessment process has been evolved and what has been the outcome of it. And obviously the background, on the framework, the frameworks on which the paradigm has been based on. We touched upon the definitions, like what's been like a hazard, exposure, and finally the risk. And then basically we moving on to the detailed discussion on to the today's topic, which are being the exposure assessment and the risk calculation. Starting on, what do you mean by exposure assessment? So basically, when it comes to a simple language, like basically who the person or the population who's been actually been engaged with that sort of MRT or the chemical or maybe the device or maybe the drug are actually being, in simple words, getting an exposure to that specific scenario. You can just try to recollect onto the paradigm of what exactly we have shared onto the pic, a person who has been actually swimming along with a shark. When does actually the risk come into the picture? When there's been an exposure. So obviously, if he's been an sporty person who actually want to swim along with a shark, then that's there comes into the picture. Okay, what would be the risk and how the risk should be calculated and accordingly. So per definition, it's basically been said like an identification and evaluation of the human population exposed to a toxic agent. And while actually touching upon the basically talking about what was being the composition of it and what's the size and basically how frequently the person has been exposed and what was been the route during. So what I was actually trying to share over the last couple of seconds has been what do you mean by exposure assessment? So basically we see a pic over here where actually we do have an like a skull or maybe the sort of an human anatomy over here, and we see a different types of exposures which can be identified, which can be for example, if there has been something being ingested and basically or maybe been applied to the skin, then basically it's actually the potential dose. And basically again basically which comes with the different units like the internal dose, finally calculating what exactly is being in the during when it comes to the in detail calculations there. Over here we are just trying to touch upon saying on the definition what is been exactly the compound that is coming in contact with the person, and basically what's the frequency, what's the route, and what's the duration, and similarly what's the magnitude of it. So moving on, here has been the stepwise three I try to create a three structure ways, basically talking about the objective, then basically the significance, and then the challenge. So when it comes to the objective, basically we all know there is no risk at all when there has been no exposure. So basically what do we mean by it is something this has been the critical element of the risk assessment process. Basically if we need to go basically into the risk assessment process only if there has been a risk. If not, then basically there has been no risk assessment being needed there. I try to just pull out as an maybe a sort of an example over here. Consider basically we are being in a regular kitchen, and we bought some cleaning spray within the kitchen, and we are trying to just clean the platform of the kitchen or something like that with that's maybe knowing having the unknown chemicals within that bottle. So basically what all we know is been something maybe the chemical can irritate our lungs through the inhalation parameters at a higher doses. And basically, like the what exactly have been the challenges that we might see, like maybe some of the challenges can include like how often the people use, or basically like how much the spray the people use per time, etc. At least those details can be provided onto the label saying like, okay, these should be the instructions, maybe spray twice or thrice per use and 3 times or 4 times a day to control the exposure. But what about the biggest challenge comes over here is been saying like, how do we know like whether the kitchen is being ventilated or not? Because it has a huge impact onto the inhalation. The particular kitchen has been not ventilated, and it has the less impact on the other side, like when it's been actually been literally been having a big door in the window or exhaust well ventilated. And at the same time, like we also don't know like maybe either the person who actively involved, or maybe the person who has actually been living along with the person, like maybe a kid or the spouse, were that actually been attacked by asthma in the past. So these are the challenges like what actually comes with the uncertainty when it comes to the risk assessment. So in simple words, we can try to identify like what's the source, type, magnitude, including the age, population, location, exposure times, and etc. But however, the real challenge remains is being about the uncertainty, like what we have discussed in the case study of the kitchen cleaner. Moving on, like what exactly have been the goals for the especially with the section 3 or the part 3 of the exposure calculations? We want to determine basically like what is being the type and the amount of the exposure, and at the same time like who all are being exposed, like what all the different types of populations are being exposed. And at the same time like basically we also want to understand like at what level of this particular thing or the drug or maybe the chemical has been trying to reach to the target tissues to initiate the mechanism, like what we have touched upon the AOP in the mechanisms lecture by Pradeep yesterday, as well as in the last session from the risk assessment. And once we determine it, like what exactly we want to move forward is being like identifying the relevant pathways. So basically like coming back and understanding the exposure scenarios, and quantifying it and aggregating it, especially when it comes to the specific exposure. Remember, the primary goal for the exposure calculation is to not to determine the type and the amount of the total exposure, but also to find out especially like who may have been exposed or how large a dose may be reaching the target tissues. Basically, this has been a key step in making the exposure assessment and finally in the risk assessment as well. Here is an example like basically like how actually an exposure can come into a picture. We all remember the food chain and the food web from our schooling, right? So basically, like consider there has been a chemical plant, and where actually it is being releasing different types of pollutants, where actually they do release the liquid effluents into the potable water or the maybe the flowing river. And then basically like there were emissions from the factory, like which are being having the different impacts, like it can deposit onto the crops, or it can basically deposit onto the ground, or it can literally be directly have the impact onto the humans. Well, actually it can be through the inhalation or the transpiration. So what happens, like maybe in simple terms or the indirect ways, like we need to consider the exposure from the big picture. What do you mean by that? In simple words, like again, to call back, like what exactly is being the direct exposure and what's the indirect exposure in this case. So let's break down the scenario there. So for example, anything that has been inhaled by the person, or maybe consider there has been a guy over here and maybe this man has actually inhaled the fumes from the factory, which could be a direct exposure. But at the same time, the chemicals have been actually been released into the water, and maybe the person or the elder person who has actually been drinking the water from the river could actually have the indirect exposure. At the same time, like we can actually see multiple things because the same water being irrigated, used for irrigation as well. So at that point of the time, the crops would literally get the double exposure, like directly from deposition of the crops as well as from the water. And at the same time, again, the cattle can also get the double or triple exposure with regards to the water, with the feed, the fodder that actually it is being fed on, and accordingly. So what's basically has been the takeaway for us from this simple picture. So we do have the different populations. Remember, like when we talked about the exposure, we talked about different patient ages, different groups. It can be pediatric, it can be a geriatric, or it can be a pregnant woman. We can actually include the sensitive population along with the children. Apart from the man and woman who are actually being healthy, considering the healthy, so the types of ingestion can be from the water, directly from the well, or maybe the flowing water where actually it is being consumed. At the same time, it can be from the dairy, or it can be from the meat, or it can be from the crops. So what exactly is being the in simple pictures, like basically if there's been a pollutant source, then basically we need to identify the exposure pathway, and then basically then linking back to the receptor, like what exactly is being and how it has been impacting the specific patient or the final end user. So here comes the $1,000,000 question. So in order to understand that, we need to really get a lot of data. For example, if I say like, okay, the water has maybe 10 nanograms of a chemical per liter. But how about like, how can we actually go back and address saying like how it is being safe across the different populations? Because the things vary, right? Like maybe a adult men, healthy men can actually consume 4 liters of water, but maybe a kid might consume just like a 0.5 liter of water, half a liter of water. So how actually we can go back and address that? So in order to address that, we actually had a couple of the supporting documents, especially from the EPA, and few of the supporting documents from even from the Netherlands government, like which was being called like RAVM. So this is the exposure factors work, which actually includes almost all the different types of exposures. So which literally call out like maybe I just tried to provide over here the updates. Like it was initially released in 1989 and then basically been recently updated in 2019. So whatever the things we see over here have been the different updates onto the different chapters. So for example, in 2017, the soil and the dust ingestion has been updated. What exactly we see within the exposure factors handbook? These are the subheadings. Like basically, we see everything. We see right from basically like what is being the water intake, or what exactly is being the like maybe a foreseeable soil intake by a toddler. At the same time, like basically like what are being the inhalation rates and what are the body weights, and basically like what would be the intake of a fish, and so on. So, for example, I just tried to provide a table over here. So, this is how actually the data has been captured within the EPA handbook. So, for example, this is the data being considered for fruit and vegetable intake. And we do actually have the per capita intake as well as the consumers intake. So, again, the details are being, the complete details have been provided, including right from infant who's actually been less than a year to that of an geriatric who actually can be of greater than to 60 or even 50. Similarly, what we see over here is been about the drinking water intake for children, and especially for children because it can actually vary, even depends to the months as well, right? So basically the infants were being classified like 1 to 3 months, then basically then 3 to 6 months, and then basically 6 to 12 months. So these are the details, like these are the real inputs that what we need along with the concentration in the water in order to just to identify the final risk for that chemical compound for that specific population. What if consider like we don't have this data? Then basically that's actually been in black hole, and then it would be not possible to move ahead with the risk assessment calculations. We need to at least get either the point method or the probabilistic method across the details for sort of this evaluation. Moving on, there were many guidelines or the being provided, especially by the EPA. We can see some of them, starting with the risk assessment guidance, RACS, which was actually we call short name as RACS, and then basically like we do have the different age groups exposure population, especially onto the different theories as well, like even to the environmental contaminants. And then basically like we do have a separate guideline for the dermal exposure, and this was the other document maybe the guideline which actually was trying to provide share the details like RIBM. This is from Denmark, I'm sorry, Netherlands. So basically this actually has a good number of tools where we will actually be delving in deeper like Consexpo and so on. But at the same time, like this includes the exposure scenarios and exposure factors. And for people who have already been working with the cosmetic or the consumer goods, like we do have the SECS, which actually provide the details like how much the amount of a particular compound would be used per person, and basically the same time like how many times a day. So these are the real inputs that we need in order to perform the calculation. So apart from that, we do have a lot many resources for the exposure factors, where we see like right from EPA to the top the WHO. We talked about the REVM, and then basically we do have some of the very good articles on which even the EPO and WHO has actually been based on, and the one which like Kohan. These were some additional resources what can be touched upon for detailed references. So, coming to this infographic, this has actually been, I love this infographic, and this infographic is from the WHO risk assessment document. And basically, like how actually they try to depict is been about saying, like, what all can be the differences when it comes to the exposure assessment. For example, there can be a different age groups, or there can be a different cultural practices. At the same time, there can be some different geographical practices. So when we see like for example like the body or the baby care products, like basically the amount used or how it is being used based on the varies as per the culture as well. And at the same time like who actually it depends on the toys, and basically even for the household chemicals. So and even the climate or basically the access to the quality of food is also varies as per the region in order to have the control onto the exposure for the final end user. So this in simple words, I would call like it's been a framework of modifying factors where actually we can try to evaluate the exposures based on according to the geography as well as being the culture. Moving on, I'm like basically we here we comes to an introduction of a term LAD, which actually we can call like LADD, and it's been a simple acronym, but however the abbreviation stands like it's a lifetime average daily dose exposure. So how actually it, we see is being this has been an example for the arsenic by soil ingestion, like what we have seen towards the end of the last lecture. I'll just try to recap that calculation because that's also a part of the exposure assessment. So in simple words, like basically the LAT formula has been something like this, like what exactly has been the concentration of the toxicant in that soil, and at the same time like how actually well, like what has been the contract rate of the specific component to the end user or to the final patient or to the final person, whoever it is, and what was being the exposure duration, and at the same time like time like these have been times like concentration times contact rate times exposure duration, and divided by body weight times lifetime. So when it comes to the like the calculations, we need to just identify the few factors. For example, the lifetime calculations would be considering the 25,550 days, and how one can ask how, but it's simple like it's considered as the 30 years of exposure, and each year consisting of 365 days. So if you just times like 30 times 365, and that's the number what you see. And body weight would be the as per the patient population what exactly it was been about, and The when it comes to the concentration to the soil, it varies as per the chemical accordingly to that specific exposure of the scenario. And at the same time, like the contact rate was found to be a constant, like in this case as 100 mg per day. And the exposure duration again it varies like on the how what was being the duration at that particular point of time. So coming back over here, like here is being the case study for the arsenic soil exposure, like soil ingestion through soil ingestion. As I discussed some time back with the exposure models, like we actually have two types of methods in simple words. One comes to the point estimation and other comes to the probabilistic methods. So when it comes to the point estimation, we try to pick up a specific point, like okay, if this particular concentration may be considered like X amount, like in this case, it was 2.3 grams per kg of concentration, was identified. At the same time, like we know like what was being the ingestion rate, and then basically like what was being the exposure duration and exposure frequency. Then basically like the considering the body weight of 70 kgs, and then basically the averaging to the time of like a total 30 years of time. And then basically coming back, we do have two more factors over here when it comes to the calculation of the lifetime cancer risk. Here we introduce the one more new term like ILCR, which is called like incremental lifetime cancer risk. And this could be for this can be for skin cancer. And here we talk about the bioavailability of that specific compound. And at the same time, like we touch base upon the Q factor, like which actually has been the slope factor. At the same time, like we do see the probabilistic methods, and basically like these are the methods like in simple terms, like basically come up with an Monte Carlo simulation, which again that's a simple tool. And how we could arrive to that details are being like there are different points of data being charted, and then finally being either 50th percentile or the 95th percentile or the 99th percentile of the data has been captured for the moving on to the next calculations. So in this case, the example like we have used the 95th percentile, and so we see the details over here saying like okay, the numbers that comes to the like 2.3 times 10 to the power of minus 5. And the output when compares like towards from the probabilistic with the point estimated methods. So these have been the important points that I try to explain or the difference between them, and we're having an advantage of probabilistic methods. So basically like it replaces the point estimates, and basically like it generates the realistic data. Like basically the exposure for a person might be at the higher end or maybe the lower end, and then basically like we try to see like at least the total population is under the 95th percentile, so that we could cover the worst case, most of the worst case scenarios there, not to leave someone who's actually been exposed at a higher concentration. If in general, like if you consider a lower percentile, like for example 50th percentile. So that's the example over here. And moving from here, there were some special considerations also being led by the agencies, and especially with regards to the EPA. Like EPA actually has one more division called it's basically the one more act called like a Food Quality Protection Act. It was way back in 90s, and where actually they tried to involve the sensitive population into the assessment, considering the children or maybe even the greater sensitive people, like for example during the development stages. And even in the coming slides, we would see some of the people like who are actually being bronchial asthmatic patients. So over here, what we try to see is been about like what are the different types of exposures. So when it comes to the like maybe in, like again when we try to differentiate, like we can call into two groups. Like one is being the aggregate exposure, and the other one is being the cumulative exposure. And how to differentiate it? So again, let me go back and touch on to the basics. Like for example, if there's been a compound who is being get exposed through different ways, like basically like maybe for in simple words, like maybe if there's been a same compound like glycerin in some of the regular daily use products like lotion or lipstick or maybe the toothpaste, the same compound can be used onto the different products, and then basically it can actually have an aggregate exposure. That's simple. That's a simple example. Like here over here, I actually tried to capture from the understanding of mine over the last couple of years. Let's take the example of nicotine. Basically, like this can be exposed through inhalation. Basically, like this can be exposed through different routes. It's not only from the different products; it can be from the different routes as well, along with the products. So in this case, it can be from a regular cigar or the cigarette, and then basically it can be a simple electronical vape. At the same time, like there are some drugs where actually the nicotine has been used as a patch, especially like who want to move out from smoking or control the smoking there. So then basically the patch would be a dermal exposure, and the vape would be an inhalation exposure. At the same time, there are nicotine or the nicotine X gums were actually being used like a chewing gum, so which could be an oral exposure. So having the control over here on three different types of exposures is being the real challenge. I would say real challenge, because it's not the same industry is actually been trying to produce all three different products in the market. So the one who actually sells vapes is out of patch and gum, and basically like the gums are being actually being the industry against to the vapes, like just to get rid of the smoking. So it comes into the picture of gums. So how actually we can go back and see like aggregate the exposure. This has been an debating topic within the industry from long, and there were some efforts being brought together, especially with some sort of concentrated groups like RIFM, like RIFM, especially for case of the fragrances and a few other products. But not really, like we have not really moved to a situation where actually we could share the data cross industry and consider the final exposure of the to the specific patient or the population. So this has been a real challenge even till today in 2025. At the same time, like we do have a couple more examples, like you see, you can read it from the screen as well. So it's been from the BPA, it can be from the like the food linings from the canned food. And basically like the BPA can also be used for the thermal papers. Basically, this has been again an interesting topic. The thermal papers are the one where actually the BPA is being used, not recollecting the exact mechanism, but let me recollect it. The BPA would be used to activate the dye upon reaching a certain temperature. So basically, like we were talking about the difference between the aggregate and the cumulative exposure, and actually how actually an aggregate exposure can happen not only from different types of products to a person, but also through different routes. So that's what's one thing like where we need to understand when it comes to the exposure, and that too especially with regards to the aggregate exposure. When it comes to the cumulative exposure, I would say like the cumulative exposure could be much easier than the aggregate exposure, because it's in again in coming back to an example for the cumulative example, like it's the same compound having the exposure from it's different compounds. I'm sorry, different compounds having the exposure to a particular person, but having the same mechanism of action. So, for example, we can see like any of the organophosphates, like working around with the cholinesterase inhibition. So, there can be many there can be many pesticides which work through this mechanism of action. So they can actually be clubbed together, and the same mechanism of action and the same clause even includes with the latest part 17 of ISO, especially with regards to the medical devices, which talks about like even if there have been different compounds coming like expecting to work on the same mechanism of action, we need to club them and actually be in work along with an cumulative exposure there. So moving from here, there were a couple more examples for the aggregate exposure. Like maybe I'm just remembering one more example over here just to make things much more easy. Which we can talk about lead. When it comes to the lead, like again, lead comes from the three different types of exposures. Like it can be from the ingestion, especially if the taps are being old, or maybe through the drinking water coming from the old pipes, or it can be from the inhalation, like which can be from the dust or maybe the industrial sites, or it can be even from the double exposure, like going with any of the lead containing products. Like fortunately, like we are not seeing any of the lead containing products recently, but in the past there used to have like we used to have the concerns with the lead containing within the lipstick, especially. So these are the details, and I hope like the members could actually try to easily identify like what exactly is being the aggregate exposure versus the cumulative exposure with these examples. So moving on, when we talked about the different frameworks or the factors or the handbooks that have been provided by the different institutions across the world. So I would call out like there are a couple of the very tools like which are actually being very much handy when it comes to the exposure calculations. So on the like on the top two, like we do have the ExpoCast from the EPA, and again as I said, like the Cons Expo from the reform. These are being Cons Expo. Again, I just want to understand or maybe make you understand basically it's what about it's been like more work towards to the consumer industry. It can be the consumer interactions, including the cosmetics or the chemicals, which comes with the daily interaction. And however, the EPA handbook literally has everything. No, it is not per sector. Like it has been a very broad one, which includes right from soil to that of the dairy to that of the water to that of the body weights. And to the last, we do have the MCRA, and again, this has been the one more acronym, like it's called like Monte Carlo Risk Assessment Tool. It's actually a tool, especially being used for with the dietary and the cumulative exposure modeling. And this works, as I said, like when we talked about the probabilistic exposure with regards to the soil exposure estimation from the arsenic. So the one which we have seen onto the bottom was being the probabilistic one, and that was actually been developed with the help of the MCRA tool. So coming back to the summary for the exposure assessment, again, we one need to understand or identify saying like what are being the characteristics of the population, like what exactly is being the age or gender or the occupation or the health lifestyle, etc. there. And then basically like who are exposed, like and basically how are they exposed is been the second point, like what has been the route, and it can be the three different routes like what we have touched on, like inhalation, dermal, or maybe the ingestion. And then basically like comes back to the point like frequency. We all know like how often an exposure happens, whether it is been in once in a day, once in a month, or once in a year, and how long the exposure lasts is been about the duration. Like it talks about like it can be last up to like 12 hours, or maybe that 72 hours, or maybe 168 hours. And finally, the important thing has been about the magnitude, saying like how much of the substance has been involved with the exposure, whether it is has been in picograms or nanograms or the micrograms. So the outcome from the exposure assessment summary has been something like we try to pull out onto the descriptive and the predictive one. So that's what we try to explain over here, like the direct measurement of the point where actually the population comes into the contact with the containment. So anything, some sort of this is being the basically talked about the descriptive one. And the predictive one would basically based on the scenarios. Those are being the hypothetical conditions and the dose reconstruction models, like how actually the exposure might have happened or accordingly. So here comes to an end for the exposure assessment summary. And then we will move on to the fourth part of the risk assessment, the risk characterization. So, if you guys remember, like the initial definitions, I try to remember, bring back the analogy of the shark and the swimmer. So, when actually the risk comes into the picture, when there has been an hazard as well as when there has been an exposure. So, saying back, I would like to reiterate, saying like there is no exposure, there is no risk, and no response being anticipated at that specific scenario. Coming back to the definitions for the risk characterization, EPA has actually put a very good handbook onto the risk characterization. I'm not recollecting the year. It might be way back in early 2000, if I remember correctly. So what exactly the risk characterization do is like it integrates the three different frameworks like what exactly we did till now. So for example, we have actually touched on the first step like hazard identification. Then basically we worked on to the dose response assessment. Then we also worked on to the exposure assessment. So we would like to merge all, like we would like to tie all these three dots to create an final meaning from the risk characterization. What should be the outcome from this scenario? Whether it is been safe or not, or things so on. We will be talking more about it. So, for example, when it comes to the this is again been the paradigm like what we have touched on. These are the this is what actually I'm trying to explain like what are being the three different parameters that was already being touched on, and here is where actually we are being with regards to the risk characterization. And the outcome from the risk characterization can lead to the risk management. That's an altogether different story, and we will also be in touch base on to the early concepts towards to the end about it. So moving on, when again we touched on saying like onto the risk calculation overview, like it integrates the hazard, dose response, and the exposure assessments. And if I coming back to the what exactly they are trying to understand, the risk characterization is the one which actually provide the key findings to the risk managers. Okay, you see a guy over here, right? Consider he's been a risk manager, and consider like maybe we can consider an example of any of the compound from the drinking water. Consider about the lead, like what we have touched on very recently. So for example, the risk manager need to understand like, okay, I do have a potable water. Consider the Cali Prop 65 document, and it has a lengthy list of chemicals which are actually being to be restricted within the potable drinking water in California. At the same time, like this risk manager need to be updated by a toxicologist from the risk characterization, saying like what exactly has been the outcome of it. Like, is it been safe or unsafe, or whether it can be controlled or not. Those things and those steps we can actually be covering in the next couple of slides. So this also evaluates, it's not only evaluates the nature, but also evaluates the reversibility of effects. So we need to have an eye on it. Coming back, we are in like coming back to the risk characterization. Over here, the outcome could be again divided into the two parts. One, if it is being a simple chemical, and basically the chemical is which is a non-carcinogenic chemical, then basically we would be having non-carcinogenic risk calculations, which could be like basically the margin of exposure calculations. And even in the past, like we used to have the hazard quotient calculations. Both are the like in simple words, like basically the thumb rule would be the same. Basically, like when it comes to the point of departure to the estimated exposure. So we will be seeing in details about the formulas, and we'll be going more dwelling more detail into the formulas in the next couple of slides. Here comes to the non-carcinogenic calculations for the any of the chemical. Basically, like ADD is being the average daily dose. Remember, don't confuse with LADD. LADD is being the lifetime average dose. What we have seen with regards to the arsenic exposure from soil, and ADD is being the average daily dose, which is actually being exposed. And basically, like RFD is being the reference dose set for the compound. And then finally, the HQ is being the EC, like basically like for the this is for the inhalation, like exposure concentration divided by the reference concentration. So moving on with the next point, like for the MOE calculations, we do have the non-cancer hazard value POD. Maybe it can be from the subchronic or the chronic study, saying like what was being the POD being derived for that specific compound and divided by the human exposure. Remember, this has been one of the very good question sometime back with the ABT. Like MOE is always been unitless. Because it's basically been the numerator and the denominator coming with the same units. So MOE is being just a number. It's always unitless. And when it comes to the oral PODs, or when it comes to the inhalation exposure PODs, then basically here are the units like mg, kg, mg per kg per day. At the same time, mg per meter cube were being considered for the calculations. And important note, for example, if there have been any genotoxic compounds, which can actually be known genotoxic compounds or the sensitization compounds, the MOE approach is being not applicable, because this can literally directly damage the DNA, and hence there has been no safe threshold of exposure can be confidently been assumed. So that's where basically like it is not recommended to move on with the MOE calculations for those set of compounds. Moving to the next part, like the quantitative results calculation for the cancerous compounds. Uh, Over here, I could call out like a couple of the compounds, like we can call out the one of the known compound like styrene, which is actually like we do have the RFD as well as the slope factor for it, which is being known for as a carcinogenic compound. And when it comes to the assessment of those carcinogenic compounds, please remember the regulators across the globe would like to see both the carcinogenic calculations as well as the non-carcinogenic calculations. So sometimes, like usually, there could be scenario where actually the styrene could be considered like the MOE would be calculated based on the RFD, and there could be a query saying like, wow, wait, good, like basically we do have the non-carcinogenic assessment being done, which has been in support for the use of that particular drug or the device. But what about the carcinogenic assessment? Like what happens when it when actually being to the carcinogenic risk for that specific compound? So again, the thumb rule for the formula has been over here is equal to like human exposure times the slope factor has been the risk, and the human like the slope factor can be the same, the units like my if it has been inhalation, it's microgram per meter cube, or if it's been an ingestion, it's like mic per kg per day, mg per kg per day. And finally, the slope factor. The slope factors were being various slope factors were being available, and especially to call out like OHA, like the Caliprop 65 document, would literally call out the slope factors for the carcinogenic compounds wherever it has been available. And for example, in case of styrene, yes, we do have one. And interestingly, there has been an at least maybe not in 25, but till some years back. There was actually been a huge debate within the agencies as well. EPA used to consider the cancer risk ranging from like 1 in 10,000 to that of 1 in a million. At the same time, like FDA used to consider the risk of 1 in 1 lakh. So with the recent updates with the M7, probably like this would be streamlined going forward. But however, these have been some of the practical incidences I just want to quote at this moment. Moving on, here has been the formula for the cancer risk for this has been for the oral and this has been for the inhalation. It's simple: lifetime average daily dose times oral slope factor, which would give you the basically the cancer risk for the calculations. And similarly, the same formula applies with the inhalation units for the inhalation as well. For example, I just want to also pull out from the practical scenario, like there has been an compound which has actually been known to be an carcinogen through inhalation. But however, we don't have the POD which actually we do like from it comes to the from inhalation. So what should we do in that case? Or similarly, like what exactly we need to from the dose as well? So in those scenarios, we typically try to go back with the dose calculations. And in this case, I just want to share one of the dose calculation for the inhalation dose from the oral dose. It's basically like oral dose times bioavailability of oral divided by inhalation. And usually like the inhalation would be considered as 100%. And if we do have the data for the oral bioavailability, then basically we could actually use the actual number from the studies, so that we could get the correct final output for the inhalation dose. If not, like one need to assume it as 100% conservatively. And here are some more factors, especially for the breathing volume, especially when it comes to the environmental settings or the occupational breathing volume settings. So moving from here, like basically like we talked about the exposure assessment and we talked about the risk characterization, which includes the carcinogenic risk as well as the non-carcinogenic risk. So from here, we try to touch upon onto the different outcomes from here, like what exactly happens later to that. And before we go there are a couple of the developments within the industry and especially from the agencies like WHO to harmonize the way the risk assessment has been practiced over the years across the globe. Please remember, they're always trying to harmonize it. Never they want to standardize it. What I mean by standard is like, okay, this is the fixed flow or the format that one need to use across the agencies or across the countries. No, it's not the matter. The point was being to harmonize the way basically the POD is being derived. Harmonize the way basically the way the assessments were being done. As I said, like for example, if there has been a compound which is known for carcinogen, then basically harmonize the way like to make use the calculations for both non-CARC as well as the CARC. And on that, like basically there are a couple more details were being provided just for the interest for the learners, like what can be referred for more details right from the methodologies to the top the terminologies. Moving from here, when it comes to the risk assessment, I would like to just share a few things there from the practical experience as well again. So when it comes to the risk assessment, if there are two well-known toxicologists across the globe and if you give the same issue to both the toxicologists, the outcome of either safe or unsafe might be the same. But the ways actually they route through or the ways they actually been navigate through or how actually it has been put through has been something different. So at the same time, this difference comes especially with regards to the uncertainties that are actually being involved within the risk assessment itself. So, for example, the two of the main uncertainties were being talked about, like touched upon, have been the variability and the lack of knowledge. Like lack of knowledge consists upon the data gaps, basically, like which can be reduced. But variability can be anything, right? So basically, it can be an Asian, maybe a person from Japan, to that of the person from India, to that of the person from US. For example, if we talk about the weight, then basically like maybe the Japanese person might be weighing like 50 kgs and maybe the Indian person or maybe the mid-Asian person might be weighing somewhere like 60 or 65 kgs towards to the maybe the Western person might be weighing around 70 or 75 kgs. This is just an example I'm trying to share because we do have the standardized ways for the weights and water, drinking water and etc. I'm just trying to give you quote an example how actually the variability can happen with regards to the uncertainty. Then comes to the probabilistic risk approach. Here, this has been actually been a quantitative approach, and this is what actually I try to explain even when it comes to the soil ingestion from the example of calculating the LAD. So over there, like we try to understand like it has been used to evaluate the uncertainty and the variability. Unlike the traditional approaches, it is not a single point one. Basically, it uses the probability distributions to provide a range of possible outcomes and the likelihood for the specific thing. So that's where we try to come up with a sort of a 95th percentile or the 99th percentile. As a practice, like most of the scientists would go with 95th percentile. And as a tool, like we do have a one more document from WHO, which is on the name, like it's again the IPCS has been the entity of the WHO, which talks about the uncertainty and the data quality in the exposure assessment. So moving from here, we also try to address the human variability. So if you remember, like some time back when we were at during the initial talk of the exposure assessment, I touched upon the specific sensitive population groups. It's not only the pediatric or the geriatric or the pregnant women, but a specific set of populations like the person who's actually been suffering from bronchial asthma. And similarly, like even addressing like the big picture of these things were being considered in the later assessments by the having the multiple frameworks by the different agencies across the globe. So over here, we can try to touch upon one of the factor like we can like basically I would like to touch upon two interesting factors like basically the ecogenetics and the epigenetics, which are actually being the far advanced regions of the science. Like ecogenetics in simple words again, to explain like how the genes might interact with the environment, and basically which could turn off a gene on and off without deregulating the gene itself. So it can be a chemical, or it can be a pollutant, or it can be from a dietary point of any of the contact with any of the compound, or it can be a drug as well. So moving from there, we try to touch base onto the genetic and the epigenetic susceptibility. So with the evaluation of the databases or the initiatives from the various agencies, there are a lot many tools were being designed and identified to identify these specific polymorphisms, and especially the SNPs, like which are called like single nucleotide polymorphisms, and which could actually be in the insertion, deletion, or the slicing, and so on. And these are being the databases which can be referred over been over here. These are few advanced concepts within the risk assessment, and basically they actually try to make use of the next gen sequencing in identifying the rare genetic variants to identify from there onto the source. If we link back, we again go back to the risk assessment paradigm. It all starts from creating a list of things like what, how, when, where, etc. So this all goes back into the early step there. And at the same time, like there can be the epigenetics as well. Like this is what I try to explain with regards to the environment, but it can also from the lifestyle as well, where the genes can turn on and off, and basically that could actually have an impact onto the final end user. Example I would like to quote over here is being a kid who's actually been exposed to the secondhand smoke, or a passive smoker might actually come across within might increase the risk for asthma attacks in the future. It doesn't like we don't have like an assurity of saying like he will, but there has been a higher risk for the asthma attacks for those kids because of the epigenetic impact. Moving from here, we do also touch base onto the different health organizations within the risk management. So basically, like when it comes to the organizations like EPA or the FDA, they all want to align with the shared goals, like especially with what exactly has been the cause that has been identified, or what exactly it has been, how it has been characterized, or and how it has been preventing the health risk. So for this instance, I would like to call back like there are different entities within the US to take example like ATSDR, the spill control, or maybe the FDA with regards to the food and the drug administration, and when it comes to the environmental agents to the EPA. So like every entity might be having a different focus, but they literally have the same shared goals to practice the risk assessment framework. So this emphasizes the proactive strategies to just avoid any of the unuse of the hazard agents in the future. That's what the outcome from here with regards to the public entities. And with regards to the prevention, basically like we do have the three-tier approach over here. So when something we do actually come across with the risk characterization, consider that there has been an exposure to that of a chemical or a compound, and say like this has been highly carcinogenic, or maybe having some major important factors, especially with some sort of specific populations. Then basically the first thing is been about to avoid or prevent. And then basically like the second step would try to come to like whether it can be mitigated. If possible, just remove that specific harmful or maybe the identified compound which turns to be an potent compound. Just move from it. And if not, then basically try to reduce the concentration or have the controls over there just to have the risk mitigated. Then basically the third steps comes to over is been about like what should be the response from the agency if there has been an accidental spill of an any of the chemicals, like maybe of an spread of the mercury within the water, or maybe the mercury from the soil pollution. So these are being the prevention steps when it comes to the public health. But at the same time, we might be well versed with the one topic called PPE in most of the companies. It's the personal protective equipment. For example, a simple goggle where actually an analytical scientist would be using while working on the HPLC is a simple PPE. So again, over here we do see the three prevention steps. The first thing obviously has been the substitution, and the second thing has been to have the any of the controls over the scenario of exposure. So if in case we are not able to control the scenario of the exposure, then basically we need to either have the engineering controls or the administrative controls. In the last line of defense, if we can't do anything about it, then basically the PP is the last interface which would again be in between of the person and the chemical compound when it comes to the exposure. Again, touching back to our own thumb rule of the old thumb rule, which again says like all the risk happens when there is only the exposure. So we are trying to get out from the risk over the scenario, so that there would not be a risk for that specific scenario with that harmful compound. Moving from there, we're actually also talking about the hazard and the capacity assessments for the public health. And in simple words, again, I just want to explain the hazard analysis has been nothing but just to identify the presence and the likelihood of the risk in that entity or the community or the region or the society. Saying like if there has been, we can just link back to the example of the big pictogram or the infographic, where we touch based or see like there has been an industry which has been actually leaving the pollutants across the ecosystem, where it may be the water, soil, or the air. Then basically hazard analysis has been something having an identification or the evaluation what can be the risk for a specific population with those scenarios. On the other hand, like we do have the capacity assessment, which actually talks about the government agency to examine and provide the response capabilities. Especially this works more, this goes mostly with the ATSDR. Any of the emergency spills or any of the things like basically like government need to handle a program like how actually they can control that, even if it's been an spill, like we used to read some few years back, there was an oil spill within the mid of the ocean. So basically, there were many agencies came together to identify and see like, okay, at this point of the time, neither we can mitigate or exclude or have a protection factor. So basically, now we need to address the scenario. So basically, how actually we can deal with that environmental pollution with regards to the oil in the water, petroleum oil in the water. So this would literally been called or the categorized under the disasters from the environmental risk. So onto the towards the last, like moving from the regular risk assessment towards the modern approaches. So we are basically while coming talking, we touched on all the traditional disciplines of the toxic like the risk assessment, including the exposure, including the epidemiology, including the animal studies, and they are going with the toxicological studies and so on. But like basically there has been a heavy work being going across the world, while touching base mostly onto the AOPs. AOPs were especially been a very big hit, especially with regards to the sensitization endpoint. We do see a lot many number of in vitro studies which came into existence because of the identification of the AOP. So similarly, like there were many works being going across with the other endpoints as well. And there were more things being going across with the biomarkers, where actually it would be an initial step where actually the our system gets reacted back and say like basically what would be the kick point for the sort of the initiation of the toxic reaction. So that's where we have been moving with regards to the modern assessment practices. So in summary, basically when I try to come back and concise all these things together, I would say like basically the risk assessment integrates both the qualitative as well as the quantitative information. Like we touch upon different factors, different things, like for example, right from the hazard identification, then basically the dose response, the identifying the toxicity, then basically identify going with the exposure assessments, and then finally touching based on the different populations, different countries, different weights, and different sensitivities. Then moving on to the geographic extensions, then basically moving on to the magnitude of response. Remember, like the magnitude is been like how big is being the spill. For example, the petroleum oil that was spill into the ocean. So if it has been an maybe 10 liters or 20 liters, might not be an issue, or maybe it might be easy to handle the emergency response team. But however, what if it has been thousands of gallons of petroleum oil been onto the water? So that would literally impact the aquatic life there. So moving from there, we try to identify the hazard and the exposure. Basically, the thumb like the assessment framework remains the same, whichever the industry we go in. So, for example, if we are being into an like the pharmaceutical sector, we go with the PD calculations, and then basically if we are being into the consumer sector, we go with the MOE, MOS or the MOE calculations. And if we are into the device sector, then basically again we go with the HQ or the MOE calculations and so on. But at the same time, the framework would remain the same even for the industry, which actually has been for the pesticides, or even for the industry for the who which actually produces the cigarettes. It's been basically the nicotine industry. At the same time, any of the environmental issues been actually been going with the risk assessment. So the whole framework that what we actually been discussed would be the basic, and the minor changes from there would be like how actually it is being applied and where to apply. For example, if it is being ingestion from the soil, we would be having some additional factors like how much of the amount from the soil it has been coming from, or versus like if we talk about like maybe from the consumer segment, if there has been a product which actually like how much of the compound has been coming from the product to the person. So at the end, it's a product coming from a source. So where it may be soil, water, product, or maybe the drug, or maybe the medical device. It's the same way it's been treated. Like what's been the exposure and what exactly has been the final risk. So moving from here, this is the final infographic I would like to share. This has been the big picture of the overview of the human health risk assessment. We started like this has been the risk assessment framework we touched upon, but I also want to share a few things like what happens before and what happens after to the risk assessment as well. So not in detail, but a brief summary just to make the people understand like what exactly really happens once I actually issue a PD, or once I actually issue an safety report, or what exactly that happens from there. So if it has been an industry, the industry would be providing the safety certificate to the specific regulators, and they're saying like ensuring the safety of the final safety of the patient or the person finally like from that particular device, or maybe the drug, or maybe the product. At the same time, if it has been your like a person or the scientist has been coming from the agency, so then basically then what happens? The agency might not be working just like the industry. Basically they don't want to sell some product or make some money there, but the agency has been more towards to the safety of the people from any of the exposures that have been happening. So for example, the best example what we have touched upon is been the ingestion of arsenic from the soil. So what the agency would say is like, okay, I have actually made the complete set of research. Like I actually have the like finally starting from the epidemiology, then the clinical studies, then basically the MOSAR, then the modeling. This information has been key to the risk assessment. And then basically in the risk assessment, the agency scientists would actually run through the planning, scoping, then basically the hazard identification, then coming to the dose response, then to the exposure assessment, and then to the risk characterization. So once the risk characterization is being finalized, we touch base, like I touched based on this particular point even in the earlier point. So the outcome from the risk characterization is being the final decision that which goes to the market or which goes to the agency or the governmental agencies. So couple of things can happen if the like basically the MOE is being pretty much less than one or maybe less than 100. Like basically like if it is being we are going with the human data, like we could go with the thumb rule of one. It should the MOE should be greater than one, and if it is being from the preclinical data, then basically the MOE should be greater than 100. So in those scenarios, what happens is like if your MOE fails, then couple more things can happen from the agency, like whether they can reduce that specific amount of the quantity of the chemical from the drinking water. Consider like maybe any of the heavy metal that is coming through the drinking water. So because they literally can't ban it, so they would try to go back and see like okay, maybe there is some more research we needed to identify or estimate or get back onto the details there. So similarly, like this has been a sort of a vicious cycle, I would say. So all three segments run hand in hand, right from the research to that of the risk assessment to that of the risk management. And the risk management can include right from the social, like maybe the social working teams, or the agencies, or maybe the legal agencies, or maybe the environmental scientists. This could lead to some bans or some additional research or some priorities to mitigate or control the risk. So here we comes to the end of the lecture onto the human health risk assessment.